It's Sunday today. Tomorrow, Monday, we'll be back down at the shed as usual, and we'll be working a little more on the Captain Fantastic pinball machine. So we ordered and received a solid state relay, and we will be testing that tomorrow. And I took our control board and added that solid state relay to it, did a little rewiring. I'd like to show you that now before we get down there, just to make it a little easier. So I decided that it would be easier to just take a picture and put it up on my computer and then do a screen capture of that picture and let you guys see that, and that way I can point to the things with my cursor instead of doing a handheld camera thing, which is always iffy. So without any further ado, let's cut to that and we'll take a look. Okay, here is our current configuration of the control board. I've made a couple of changes since you've seen it last. First, I've added another 8-port solid state AC relay board to the bottom right here. And the reason I added that board is because this mechanical relay board had 3 relays that were going to be used to control AC solenoids. And since I'm planning on getting rid of this mechanical board, I needed something to handle those 3 solenoids, so those will now be handled by solid states just like this one. I've also added this solid state DC relay to the board for testing. And as you can probably see here, it says the control is 3 to 32 volts. I have checked it out with a 3.3 volt signal directly off the processor and a 5 volt signal that comes off of this port expander. It seems to work fine with both of those. At least the red blinking light right here does blink, so I do believe that it is functioning correctly. And the output, it's a little hard to read on here, but it's 5 to 220 volts DC, so that should handle our 50 volt DC solenoids just fine. Now, the reason that I've left the mechanical board on here is because I noticed when I was reviewing the footage from the last video I posted that the 3 thumper bumpers have flyback diodes on it to suppress the arcing when the mechanical or when the magnetic field collapses when the solenoid turns off. The 2 slingshots do not, which means they will produce a very high pulse of electricity, which will cause a very strong arc. And that putting a flyback diode on that coil may be all it takes to make this board fully functional. So we do want to test that out. I'm not sure if the solid state works. We may switch them out to that anyway. We haven't made that decision yet. But the one thing we are going to do is add some flyback diodes. So I'll see if I can pull up last week's video and catch a screenshot of those 2 spots where I could see the diodes and not see the diodes, and we'll review that with you to show you what we plan to do. Okay, here's a screen capture of 2 of the thumper bumper solenoids, and as you can see, my finger was pointing at the solenoid, but between these 2 contacts, the 2 main power leads coming into the solenoid, you can clearly see this diode between those 2. And actually, if you look over at the other solenoid over here, you can see the diode connected across those 2 also. Now, here is a picture of the slingshot solenoid, and you can see the wire that's coming from the switch that activates the slingshot, and you can see the other wire over there, and there are no diodes on this slingshot solenoid. So we will be adding that diode when we get there tomorrow to test to see if that cuts down on the arcing. Okay, it is Monday. We are back down at the shed. We have another guest star here tonight. Say hi, Trevor. Is that right? Spencer, Trevor. Trevor is his son. And I was tutoring him for a while. I never could get their names straight, though. So anyway, he is here tonight to learn about modifying pinball machines from us, air quote, experts. Mike just walked outside, but he's here also. So what we are going to do today is see if we can find out whether a diode will help cut down on the arcing of this thing. We've hooked two wires back up to it. They're hanging right here, and there they are. There are the ends. And the first thing I'm going to do is just turn this machine on, and I'm going to tap these wires together to see how much they arc, and then I'm going to add a diode across the coil and do it again to see if it reduces that arcing. So that's the down and dirty test that we're going to do. So we'll get the machine turned on, get set up, and then we'll be back. This should be recording. So we'll take a look at the arcing without the diode. That's pretty significant arcing. Okay, you want to turn it off? You can hit the stop button. So we've added a 4007 diode across this coil, and we're going to see if that will cut down on the arcing at all. So you want to look down here, and we are still getting some arcing, but it doesn't look to me as bad as before, so we'll go ahead and hook it up to the relay and see what it does.
And I don't hear the buzzing anymore.
Yeah, we have the relay hooked up. We're pulsing it about once every 5 seconds or something like that. It seems to be running fine, and right now the relay is not getting warm at all. It's ice cold. We do believe, or at least I believe that, or I have a theory, let's put it that way. I have a theory that the relay didn't start getting hot until the contacts fused and it was drawing continuous current through it. So since this one hasn't fused, it's not causing a problem. But what we're going to do is we're going to speed it up so that it fires about 3 times as fast, and see what that does, see if it causes any problems.
That oil's getting a little warm.
Okay, we have increased the pulse time to 1 pulse a second. Our relay is still ice cold. It's not having any problems. Mike touched the coil, said it's getting a little warm. And back there, you can kind of see the count. We've done 540 cycles of this thing without anything going wrong. So it does look like that diode may be the cure. So we do want to test the solid state relay just to make sure it works. So we're going to go ahead and hook that up and take a look at that next.
So we're going to have to do the programming to control that.
So we have the wire hooked up to the DC solid state relay, and as you can hear, everything seems to be running just fine. We're up at 84. We really up to 84 already? Yeah. So we're up to 84. We'll run a couple of hundred of these through here to make sure that it works, and then we'll call it good. Okay, we are satisfied that the diode does indeed stop the arcing enough that we don't have to worry about our relays arcing over and shorting out, and the solid state DC relay also functions, so we have 2 solutions. So we're comfortable that we have a way to control all the solenoids in this machine now. So you can take a look at this and say goodbye to all of this wonderful, wonderful old mechanical stuff in here, because we're going to rip it all out. The only thing that will be left in this box down here are the coin mechanisms, the chimes, of course the very important tilt mechanism, And way back there in the back, which I don't know if you can see on the back left there, is the transformer. We will be keeping that to generate the power for our relays. On the back here, the stepper switch here will be going away. There's a control relay there, another control relay there, and another control relay there. Those will be going away. Of course, all the light sockets will be going away, and we will be wiring this with a different type of LED string. We're going to be using RGBW LEDs. They actually have a white LED on them. You don't make white by turning on all the different colors. They look a bit brighter and a lot cleaner color in our opinion. So we'll be using those in this build. So we'll show you a little bit about those in an upcoming video. And that's it. There is this little section right here is the DC power supply. That black box down at the bottom there is the bridge rectifier, the fuse holder, and a really grungy old capacitor, which we'll be replacing with a new one to provide the DC for the 5 solenoids, those 3 right there, and the 2 thumper bumpers up here. So that's it. The rest of the relays are AC, although we were talking about potentially swapping out the flipper solenoids with DC solenoids, because those buzz an awful lot when you're holding them in just to hold and catch a ball or something. So anyway, we'll see about that as we go along. So anyway, that's it. Our next step is to start ripping all of this stuff out. Also, just because that isn't all of the mechanical controls, back here in the back, there's also quite a bit of controls, and let me see if I can move around a little bit. We are going to keep the score wheels, I've mentioned that before, and we're also going to keep the credit wheel, but things like that stepper switch and all of these jumpers and all of these control relays right here are all going to get ripped out. So there's some more jumpers there. So anyway, that's all going to get rolled out. There's another stepper switchy thing here that's going to get ripped out. And on the score wheels, the only switch that we use is the 0 switch, and that's just for synchronization to make sure we've actually gotten to 0. So we're going to take out all of the little slider switches that are on these score wheels and disconnect all of these unused switch wires. We'll probably leave the switches in just to keep the stack intact. But that's it. So there's quite a bit of stuff to do. There's also another bank of relays mounted up on the wall up here, or on the ceiling, I mean, and those are going to have to be ripped out also. So that is it. I think that's going to end the video for tonight, probably. But we'll get back to you when we start ripping the wires. So I lied about not filming anymore. We did decide to start stripping the table down. So we've started removing all of the plastics, bumpers, rubbers, flippers, and stuff off of the playfield here. And we'll probably flip it over on the table once we get this side done and pull everything off the back. Mike does have a new playfield that all of this stuff is going to get remounted on, so obviously it'll be taken off, cleaned up, or replaced depending on what it is, and then we'll put the new one together with the LEDs. Okay, so we have removed the playfield from the table, and we have set it on here. We have the top side almost completely stripped of components, except for the ones that are screwed through to the back. So now we'll start taking all of our mechanics off of the back. Well, we've been working for about an hour at ripping out wires, cables, relays, light fixtures, nut plates, all sorts of stuff. And as you can see, we've done quite a bit of damage to the board already. Again, we're going to strip everything off of here, and then we'll bring the new table in and start repopulating. So after 3 people working an hour and a half, we have taken everything pretty much off the back of this. There's a few things still stuck on the other side, like the thumper the thumper bumper pieces and the drain there. So we have to flip it over and do a little bit more on the other side, but then we'll be completely done. And there we go. Mike, you want to lift it up to show them the other side, just to prove that we've done our due diligence and completely stripped the board all the way down. That's actually a really nice looking board, all things considered. A little polishing up and it'd be as good as new. But we got a different one, so we'll put the brandy new one on. Okay, so this is definitely it for the night. Thanks for coming by and helping us. It was a pleasure having you. Mike, we'll see you later.
All right.